Today's notes are the beginning of solving inequalities. We will be solving inequalities over the next several class periods. We solve inequalities exactly the same way we solve equations. There's just one additional rule, one more thing we need to keep track of. And this one additional rule is sometimes we need to flip the inequality around the other way. And we do that if we multiply or divide both sides by a negative number. If you multiply or divide both sides of the inequality by a negative number, the inequality must be flipped. Every part of that statement is important. First of all, we only flip the inequality if we are dealing with multiplication or division. So it's only if we multiply or divide, not if we add or subtract, even if we're dealing with a negative number. Only when we multiply or divide. Also, it has to be both sides. If we are distributing a negative number, that's technically multiplying by a negative number. It has to be done to both sides in order to flip the inequality. And then, of course, by a negative number. So just because we are multiplying or dividing both sides does not mean we flip the inequality. We only do it when we multiply or divide both sides by a negative number. In that case, we flip the inequality. What I mean by flip the inequality, that means if it was less than, we are then on our next step going to change it to greater than. If it was greater than or equal to, on the next step, we flip it around and we write it as less than or equal to. So we flip the inequality, it opens up the other way. So again, we solve inequalities exactly the same way we solve equations. There's just one more rule we need to keep track of. That one additional rule is if you multiply or divide both sides by a negative number, the inequality must be flipped. So just one more thing we need to keep track of. That's good news if you have done well with solving equations. All of the steps, everything's going to be the same. We just need to remember this one additional rule. Also, if you struggled with equations, the next few class periods will be a good opportunity to review our steps on solving one-step or two-step or multi-step inequalities instead of equations, but there's really just one more thing we're adding in. So this will be a good time to kind of go back and relearn our steps for solving equations as well as inequalities. So example 1 asks us to solve each of the following inequalities. We are also asked to graph our solution. Solve the inequality and graph your solution. So we are given x plus 7 is less than 3. We solve this exactly the same way we solve an equation. So our equal sign, or not our equal sign, but our inequality sign right now is right here. We want to think about what is happening to x. We are adding 7 to the x. We undo addition by subtraction. We want to subtract 7 from both sides of the inequality. These cancel. I get x. 3 minus 7 is negative 4. And then every single step when we rewrite it, we want to decide, should I flip the inequality or not? In this case, I subtracted 7 from both sides. Even though it's a negative number, I did not multiply or divide. Therefore, we do not flip our inequality. X is less than negative 4. It also asks us to graph the inequality, so take a quick minute to sketch in a number line. We worked on graphing inequalities last class. Negative 4 should be on our number line. As we get bigger than negative 4, this is going to be negative 3, negative 2, negative 1, 0. As we get smaller than negative 4, this is negative 5, negative 6, negative 7, negative 8. So we should label at least a couple points on each side of the value we want. It's okay if you don't label every single number. We need to decide if we have an open or a closed circle. Because x cannot be equal to -4, it does not have the or equal to there, we are going to use an open circle. We don't color it in to indicate that we are not including -4. And in this case, -4 is bigger than x, and I'm trying to shade in x. So if -4 is the bigger thing, I want to shade in to the left. Part B. Part B says 5 is greater than x minus 10. 5 is greater than x minus 10. Again, we want to think about what's happening to our x. In this case, we are subtracting 10 from x. We undo subtraction with addition. We want to add 10 to both sides. My x comes down. 5 plus 10 is 15. Every step, we should decide if we should flip our inequality or not. In this case, I added 10 on both sides. We only flip our inequality if we multiply or divide both sides by a negative number. We did not multiply or divide. Therefore, x is less than 15, or 15 is greater than x is our solution. It also asks us to graph. 15 needs to be on our number line. 16, 17, 18, 19, 14, 13, 12, 11. The circle again should be open. 15 is bigger than the x. 15 is bigger than my shading, so I shade this way. Part C, we are given g minus 5 is less than or equal to 6. G minus 5 is less than or equal to 6. Add 5 to both sides. My g comes down. 6 and 5 make 11. I add it on both sides. I don't flip my inequality when I add. G is less than or equal to 11 is our solution. On the number line, 11 needs to be on there. G is less than or equal to 11. 11 should be part of my solution. I have a closed circle. 11 is bigger than the G. I'm trying to shade in the variable, in this case G. So 11 needs to be bigger than my shading. So once again, I shade it to the left. All of these are one-step inequalities. We're only solving one-step inequalities today. As well as taking a look at a couple story problems. If you are taking good notes, you don't need to write down every word there, but you should at least write down what I highlight. It says a school is selling reflectors for Bicycle Safety Day. That probably doesn't need to go in your notes. Each member is encouraged to sell at least 50 reflectors. So we need to sell at least 50 reflectors. You sell 17 on Monday and 12 on Tuesday. We are asked, how many reflectors do you need to sell on Wednesday to meet your goal? we are asked to write an inequality and solve it. So again, we are asked to sell at least 50 reflectors. You have sold 17 on Monday and 12 on Tuesday. How many do you need to sell on Wednesday to meet your goal? And you might be able to figure this out without writing an inequality and solving. Let's make sure we understand how to do this one, so that once the problems get a little more complicated, we're used to setting up inequalities. So we need to sell at least 50 reflectors. So the number of reflectors that I sell, I'm going to put reflectors, needs to be at least 50. So 51 would be okay, 52, 53. The number of reflectors I need to sell needs to be bigger than 50. At least 50 includes 50. It'd be okay to sell 50. The number of reflectors you sell needs to be greater than or equal to 50. We're going to call X the number that you sell on Wednesday. X is the number that is sold on Wednesday. So the number of reflectors you have sold, we had 17 on Monday, plus 12 more on Tuesday, plus X on Wednesday. We don't know how many we are selling on Wednesday. Needs to be greater than or equal to 50. It asks us to write an inequality. We have done that right there. And then we need to solve our inequality. Combine like terms right here, 17 plus 12. We can combine those to 29. I have positive X. I am adding 29 to that. So I need to subtract 29 from both sides. $50 minus 29 gives me 21. X, which is the number that you need to sell on Wednesday, needs to be greater than or equal to 21. You need to sell 21 or more reflectors on Wednesday. Let's take a look at these inequalities. Inequality. Extra I in there. Solve the inequality and graph. In number 1, we are given 4D is less than 28. 4D is less than 28. Remember, a coefficient right next to a variable means that we are multiplying. We undo multiplication with division. We are going to divide by 4. If I do it on the left side of my inequality, I need to do it on the right side of my inequality as well. I get D, 28 divided by 4 is 7. I divided both sides of my inequality. Should I flip the inequality around? I only flip my inequality if I multiply or divide, I did that, both sides, yes, by a negative number. I did not divide by a negative number, therefore I do not flip my inequality. I think we're getting good at graphing it. We're going to work through that very quickly. There is 7. It should be an open circle, and it should be shaded to the left. D is less than 7. Number 2. Number 2 says negative 3x is less than or equal to is less than or equal to 18. Negative 3x is less than or equal to 18. Looks very similar to the previous problem. I've got a number times a variable. I undo that multiplication with division. We want to divide both sides by negative 3. We get x positive divided by negative. It's negative. 18 divided by 3 is 6. I did divide both sides by a negative number. Therefore, yes, this is when we flip our inequality around. If we divide both sides by a negative number, our inequality needs flipped. Again, graph it on the number line. -6 needs to be on there. As I get bigger than -6, it should be -5 and then -4. I'm getting closer and closer to 0 as I get bigger with negative numbers. I should have a closed circle on the -6. I want my shading to be bigger than the -6, which is this way. Number three says x divided by 8 is less than or equal to -2. X divided by 8 is less than or equal to -2. X is being divided. We undo division with multiplication. So I am going to multiply by 8. 8 divided by 8 cancels. Negative times positive is -2 times 8. We did multiply both sides, and I'm multiplying with a negative number, but I multiplied both sides by +8. I did not multiply both sides by a negative number, therefore I do not flip my inequality around. Again, it is only if you multiply or divide both sides by that negative number. And we can graph. Closed circle on -16. Shading goes to the left. Notice if I had changed this problem, if it was x divided by -8, so I multiply both sides by -8, negative times negative is positive. When I multiply both sides by that negative number, I would have flipped my inequality around this way. Last problem. It says a science club charges $4.50 per car at their car wash. So again, highlight the important parts, $4.50 per car. Write and solve an inequality to find how many cars they have to wash to earn at least $300. The science club is charging $4.50 per car at a car wash. We are asked to write and solve an inequality that is going to find how many cars they have to wash to earn at least $300. So again, I would start out by just writing it kind of in word form. The money that they need to earn, money earned, needs to be at least 300. So at least 300. 300 itself would be okay, or equal to. At least 300 means they want to earn more than 300. 301, 302, 400, 1,000. The money earned needs to be bigger than 300. Or it could be equal to 300. They are earning $4.50 per car. I'm going to call number of cars C. So the money that they earn $4.50 for each car. So 450, 4.50 times the number of cars that they have. If they have one car, we do 450 times 1. If they had 2 cars, we do 450 times 2, or 3, 450 times 3. We don't know how many cars, so it's 450 times C. So we have 4.50 times C is greater than or equal to 300. Because we are multiplying, we undo that with division. You would be allowed to use a calculator to do this division. I get C is greater than or equal to 66.67 cars. The problem is they cannot wash 0.67 of a car. They can wash one car or two or three or 66 or 67. So maybe a better question here in the problem would say, what is the minimum number of cars that they need to wash? What is the minimum number of cars to be washed? Usually we would round this to the nearest whole number. With inequalities, we don't necessarily want to do that. Because the number of cars has to be bigger than 66.67, the closest number that is bigger than 66.67 is 67. 67 is the minimum number of cars that need to be washed to earn at least $300. That is a wrap for today's notes. We will be back at it next class.